Hi guys, in these videos we're going to talk about just the Unit 8 and reviewing, and I wanted you to kind of just know, like Unit 8, there's a lot to it. The first thing we talked about was average value. The average value of a function is when I had this like integral from a to b, and it was 1 over b minus a, and then whatever this function value was, if it was talking about velocity, that would be average velocity. If the function was acceleration, it would be average acceleration. It's just the average of whatever this function is all about. Then we talked about position, velocity, and acceleration with integrals. So you'd have like total distance traveled, all that stuff. These first couple videos are talking about areas and volume. So let's go and just get into it. The first question, I've got my notes by me, so hopefully I don't make any mistakes and lead you on to the wrong answer. The region enclosed by the x-axis, the line x equals 3, the curve of square root x, and it's rotated about the x-axis. What is the volume of the solid generated? So on these questions, I'm going to start off by drawing a picture to see what I have. So I've got the line, the x-axis, the line x equals 3, and then the curve square root x. So it kind of looks like that. Now, from here, I know, okay, this is the part, that's my 2D shape, and I'm going to rotate it around the x-axis. And if I do that, 3D shape is formed, and I want to find that volume. But in order to get volume, I integrate an infinite number of areas. So I need the area. But to get the area, it's the area of what shape of the cross-section. The cross-sections are always circles, so I need the radius value. So the cross-section is going to be this circle and this circle. They're always going to be circles. They're always perpendicular to the x-axis. So the next thing I got to figure out, okay, well, what represents the radius for any given function or for any given value of x? So by the way, these always are going to be in x terms. If I'm rotating around a horizontal axis, which looks like the x-axis, it'll be in x terms. If I was to rotate around a vertical axis, like the y-axis, everything needs to be in terms of y. So the radius at any moment, if I was making my cross sections, it's just the function value, the square root of x. So if that's the radius, I get the area of a circle by doing pi times the radius squared, but the square root of x squared would just give you x. So the area is pi times x. So the volume, usually you put the pi out in front. So the volume is, you're adding up an infinite number of circle areas. And I would start at 0 and end at 3. That's where my cross-sections start. Cross-sections start at 0. And what this is doing is adding up it's plugging in every value of x from 0 to 3. And it's getting the area at that moment. And then it's compiling all those, it's adding them all up, and it gives us a volume of a solid. So I would need to integrate this from here, which would be, okay, the antiderivative of x, reverse power rule, x squared multiplied by the reciprocal of 2, which is 1/2. So there's a pi out in front, and we'll evaluate that from 0 to 3. So this is the fundamental theorem of calculus. So we are plugging in 3. So I have 1/2 of 3 squared, which is 9, minus, so I plugged in 3 first. Then I'll plug in 0, but if I plug in 0, I just get 0. So this would be 9 over 2 pi. So the answer would be C. All right, number 2, calculator's not allowed. We want to find the area of the region bounded by the lines x equals 0, x equals 2, and y equals 0, and the curve, this thing. With no calculator, we got to be able to kind of get an idea what this looks like. So I'm going to sketch out my graph. And some of you might not have to sketch out this graph. I need to, just to see which one, which function's on top and bottom. All right, so x equals 0 is the y-axis. X equals 2. Y equals 0 is the x-axis, so this is x is equal to 0. This is x is equal to 2. This is y is equal to 0, and the line y is equal to e to the power of x over 2. So I'm going to plug in 0 for x and see what the y-intercept is. So y is equal to e to the 0 over 2. E to the 0 is just 1, so that first value right there would be 1. And then I might plug in 2 also. I'll plug in 1. Y is equal to the e to the 1/2. Or I don't know what that is, square root of e. I don't know what that is, so I'm not going to bother. Then I have e to, or y is equal to e to the 2 over 2, which is 1. So that's just e, so like 2.72. So maybe it's something like that. So there's your shape. This is the shape that we're trying to find the area of. To find the area, we just integrate the function, the top function minus the bottom function. So if I'm integrating an infinite number of y numbers, basically, I'm integrating an infinite number of lengths, it gives me area. So the area is equal to the integral from 0 to 2. That's where where it starts and where it finishes. And then top curve minus bottom curve. Top curve being e to the power of x over 2 minus the bottom curve, which happens to be 0 this time. But if that had been 1, I would find the area of top curve minus bottom curve. So it would be like a 1 right there. But that's not the question, so let's don't mess things up. So minus 0, don't need to write that. So I'm going to take that away and just do dx. So now I have to actually find the answer of this now. So this is a good question, because to find the antiderivative, I need u substitution, where u is that x over 2, du is equal to 1/2 dx. Now from here, I'm going to write it the long drawn out way. Some of y'all kind of do the shortcuts. You kind of see how it all goes together. But what we're doing is we're multiplying this whole function by 1 over du times du. If I do that, the value doesn't change. Like this number that this was, because this would be a number, right? If I multiply this by 1 over du times du, that's basically multiplying by 1. So that doesn't change the value of anything, but it rewrites it in terms of u's instead of x's. It makes it easier to integrate. So I'm going to change my limits of integration. Don't forget that. So 0 over 2 would still be 0. But plug in 2 for the x. 2 over 2 would just be 1. This would be e. And I'm going to replace x over 2 with u because that's what it's equal to. And the dx is still there. Okay, in this next step, this is when I would rewrite what du is. So I'm going to erase du, and I'm going to replace it with what du is equal to. That's that 1/2 dx. So now that allows me to cancel out these dx's. And if I've got 1 divided by 1/2, that's 2. Go from 0 to 1, e to the u, du. And if u sub doesn't make sense yet, just keep working at it. Keep working at it. At some point, it'll click for you. If it hasn't clicked yet, you're smart. You'll get it. It's just taking us some time. So just keep working at it. Okay, from here, I bring out this 2. That was supposed to be motivational. Hope you're motivated. So it needs to be e to the first power minus e to the 0 power. And so that would be 2 e to the first power minus 1. Anything to the 0 power is 1. So the answer is C again. All right, good work. Next one. Oh, this is a fun question. And by fun, I mean ridiculously difficult to understand at first. But once you get it, like everything, you get it. All right, calculator not allowed. Great. It says the region bounded by the x-axis and part of the graph of cosine of x between negative pi over 2 to pi over 2 is separated into two regions. It's separated by this vertical line y equals some number k. If the area of the region from negative pi over 2 to k is 3 times the area of the region for k to pi over 2, then what is k? Okay, so let's graph y equals cosine of x. Okay, from negative pi over 2 to pi over 2. Let's just kind of get a visual of what's happening here. All right, so I'm gonna say from negative pi over 2 to pi over 2. And I've already done this question, so I've thought about it, and it's taken me forever, but that's why it's gonna look a little bit easier when I do it. So I gotta graph values of cosine between there and there. So we know cosine looks like this, right? And hopefully we kind of remember that cosine is the one that starts up high, and then it kind of just oscillates. So if I didn't know that, I would plug in 0. Cosine of 0 is 1. So there's one number. And then if I plug in negative pi over, sorry, let's put pi over 2. Cosine of pi over 2, that's like 90 degrees. If you like degrees, so straight up on the, whatever, pi over 2 radians. So cosine of pi over 2 is 0. That means cosine of negative pi over 2 is also 0. So the graph kind of looks like that. And what we're trying to find is some x equals k number. So x equals something so that this side is 3 times as big as this side. So this whole arc sine of 1/4, arc sine of 1/3, honestly kind of scares me. I'm not sure what that is. Hopefully that's not an answer choice. I'm thinking, I know pi over 6, pi over 4, and pi over 3 is always in that first quadrant. So it's like in between these two. So those kind of make sense to me. So if this is an FRQ, I'd probably just, like if I didn't know exactly what to do and I didn't have time to do it, I at least have a 1 in 3 chance to guess the right answer. But I don't know which one I would guess. That'd be hard. All right, so enough messing around. So I don't know where this k is exactly. This k number, it could be more over here, it could be right here, but I know that it says this size, or this side, that region on the left side from negative pi over 2 to k is 3 times the area of this part, which I'm going to say like that's the green one. So the color might help you. So I need to find I guess the perfect number that would make that happen. So I'm going to set up an equation. So I know it's going to be an equation, and 3 times the green side would have to equal the red side like it is. Now the red side, I don't know why I'm explaining like this, the red side, that red area, I gotta think, okay, well what's a expression that could be used to find the area of that region? You're like, I don't know if I've ever done this, but we have. We just did it right here. The area of a region, the area between two lines, why am I erasing? Is I'm adding up the distance between the two of them. I'm adding up line segments, an infinite number of them, and it gives me an area. So to find that volume over here, it would be, or sorry, the area, it would be the integral from negative pi over 2 to k of, what is this function again? Cosine of x. That would be equal to that, right? And k is just some limit of integration. It's some number here. If we don't know what it is, we can still like find it. And the green area would be the integral from k to pi over 2 of cosine of x dx. And if I solve this equation, there's only one, like if I integrate it and plug it all in, I can solve it for k. So seeing this now, it might make more sense. Coming up with this like on the fly is kind of crazy. But if you've seen one like this, maybe if we do this someday, if you see a question like this again, you'll get it right. All right, so let's actually integrate the left side. If I integrate the left side, antiderivative of cosine is sine, evaluated from negative pi over 2 to k. And then the green side integrated, and I'll just have that 3 is just there now. Antiderivative of cosine is sine again. And I'll integrate from k to pi over 2 positive. And then we just keep solving this. So plug in k, sine of k, minus sine of negative pi over 2 is equal to 3 sine of pi over 2. So plugging in pi over 2, then plugging in k, subtract 3 sine of k. So now we can solve this for k. All right, so sine of negative pi over 2. Crud. Okay, negative pi over 2. So sine of pi over 2 is that way, right? So negative pi over 2 is this way. The sine there, sine is the y-coordinate. So the y-coordinate down there is negative 1. So this is negative 1 right there. But since this was negative 1, this will be positive 1. So it's sine of k plus 1 is equal to sine of pi over 2. So that's pi over 2 up. Sine is positive, so it's 3 minus 3 sine of k. All right, subtract 1 and get 2. Add 3, get 4 sine k. Divide by 2, or sorry, divide by 4 and get a half. So now this is saying sine of what gives you 1/2. So this is where you got to know that unit circle. So I know sine of all this stuff. This is radian pi over 6. This is pi over 4. That's radian pi over 3. The sine is the y number, so this number I know is root 3 over 2, 1/2. So sine of what gives you 1/2? So it would be pi over 6. Whoo-wee. That was a fun question. C again. So if you just guess C, I guess you get it right. All right, so hopefully that makes some sense. Maybe rewatch that and like, oh, wow. That was something. I bet you can come up with that again if you see it again someday. All right, we'll do one more multiple choice, and then we got a free response. Then I'll take a break, go play with my kids, and then come back and make some more. You didn't need to know that. Okay. Calculator allowed. Yay. The base of a solid is the region in the first quadrant bounded by the y-axis, the graph of tangent inverse of x, and the horizontal line y equals 3. The vertical line x equals 1. For this solid, each cross-section perpendicular to the x-axis is a square. What is the volume of the solid? All right, we're going to get a picture. Draw a little picture. There's your x and y axis. Y equals 3 up here. And this is calculator active, so you can plug this into your calculator. X equals 1 right there. And then tangent inverse, I think you got to know this. Looks like this, where it's got an asymptote at pi over 2 and negative pi over 2. I don't know if we've added that to our member sheet yet. We'll probably will soon. So that tells me this kind of goes up like this. So pi over 2 is not quite, so maybe a little less. All right, the region bounded by all those lines. Why is 3? Horizontal line y equals 3. Uh-oh, I didn't even think about this. What is that even about? Who cares about y equals 3, right? The base of the solid in the first quadrant bounded by the y-axis. All right, there's the y-axis. The vertical line x equals 1. Each cross... Oh, so is it this shape up here? Is that the shape? Wow, I might have done this wrong on my notes. Yeah. So, I'm nervous. All right, for this, okay, let me say it again. The first quadrant bounded by the y-axis, okay. The graph of tangent, yeah. Horizontal line, that. So this is the... Oh no, I don't know what the answer is anymore. When I did this earlier, I got B, but I drew it wrong. So I guess this is a good show you this. Even the teacher doesn't know how to do this stuff, so it makes you feel a little better. All right, so, or worse. All right, so what are we doing? So there's your base. The solid coming out, each cross section is going to be a square. So bigger square there, slightly bigger, less big there. The list is going to be over here. So there's shapes coming out, and we're going to add up an infinite number of those square areas. So to find the volume, I'm going to add up or integrate an infinite number of areas. And they'll all be side squareds, because it's a square, right? Length times width, same side, okay. And I'm going to add them up from 0 to 1. Each side length, so to find the side, it's going to be the distance from, let me highlight this. It's going to be this, you can't see that. It's going to be this distance right here. Anytime I want to find the distance between two curves, I do top curve minus bottom curve. So top curve is 3 minus bottom curve, which is tangent inverse of x. So that's each side. The area, because this is a square, would be 3 minus tangent inverse of x squared. To find the volume, I integrate that. And without a calculator, this would be a nightmare. So let me plug this into the calculator and see what I get. I need to make a correction to the answer key that I posted because I think that's wrong. All right, so I'm typing in Desmos, int, the integral pops up. Limits of integration would be from 0 to 1. Parentheses, 3 minus tangent, do the little a to the b thing, negative 1. And I think as you're doing these, you should practice typing these into Desmos, because Desmos can be a little funny sometimes, and if you do something wrong now, you can ask and try to figure it out. Don't forget to put the dx at the end, and I get 6.61233. Oh, so I still got the same thing, but I think I just drew the picture wrong. Oh, maybe that was right. Never mind, it's right. My graph just kind of looks wrong. I mean, I just can't draw graphs. Anyways, okay, so that's the right answer. It was D. Not too bad. All right, next one. Let's do an FRQ, and I'll take a little break. That way I don't get too tired sounding and dull sounding, like y'all said. I'm going to leave the comments on here, so if you do see something that was wrong, like if I go on for 5 minutes about a question that was wrong, like you can just tell your classmates, hey, when you did number 4, it's actually just C, so just skip to the answer or whatever. All right, FRQ, calculator is allowed. This was number 1 on the 22 AB and BC test. So actual FRQ from back in the day. So in this figure above, R is the shaded region in the first quadrant that was bounded by the graph of y is equal to 4 natural log of 3 minus x. So that's this part right here. And they gave us a picture, that's kind of nice. The horizontal line y equals 6, and the vertical line x equals 2. So there's R. Find the area of R. Okay, on the FRQs, you can't just plug this stuff into your calculator and say 6.8166 whatever. You can't just do that. You have to write the stuff you plugged into the calculator, basically. So they need to see, to find the area, you know you are integrating an infinite number of line segments. And I'm integrating them from 0 to 2. Because I'm going to get these cross sections, I guess, these little lines, going from left to right. So they'll be in terms of x. This is y is equal to 6. So to get the top curve minus bottom curve, top curve is always 6. Oops. And bottom curve is that 4 natural log of 3 minus x dx. So when I'm plugging this into my calculator, I'm going to do this into Desmos now because I didn't do it before. I did it on the little graphing calculators. Let me see what all could go wrong if I'm typing this in. Like, do I have to have parentheses? I don't think so. So 6 minus 4 natural log, oops, parentheses, 3 minus x, close parentheses, dx. And nothing happens. It's got a little, it says integram must end with an integration variable like dx. And it did. But what is happening? Okay, you're not seeing what I'm looking at. I typed this into the calculator just like it looks, but it's saying that's an error. So what it says is it's looking at this, and saying that's the integral, and you subtract whatever this is, and it's all confused. So to make sure this works, put an extra parentheses around the integrand. What you are integrating is called the integrand. So put parentheses around that, and then it works. So I would say 6.81665, answer. So on the calculator active, put the decimals, put the decimal spot, then 5 numbers, don't worry about rounding. That would give you full points right there. All right. Part B, find the volume of the solid generated when region R is revolved around the line y equals 8. So y equals 8 is up here. If you're watching this video during the, I guess we call this the ice, the weather, but bad weather, we haven't learned this yet. This method is called the washer method of finding a volume of a solid. So it's a disk method if I'm revolving around a line where my region is butted up right up against it. There's no little space. But the washer method is used when they're each, once this is rotated around, there's like a little void in between. And then on this side, what would it look like? Just picture this is going up. So as this is rotated around, this thing is 3-dimensional. But there's a void in between. So this would all be solid, but there's a space in between. Any cross section is going to be a washer. So it's a circle with a part missing in the middle. So to find that, it's still an integral. It's a volume is equal to the integral of the cross sections from 0 to 2. And we call this the big R. The big radius, I wish they wouldn't call that big R right here. Big R is the distance from axis of revolution to the furthest away on that shaded region. And then little r is the void. It's the distance from the axis of revolution to the edge where there would be nothing. So big R, we would call that the distance from the blue distance. Okay, if I want to find the distance between 2 points, it is always top function, which is 8, minus bottom function, which is 4 natural log of 3 minus x. Then I say minus little r. The distance between 8 and 6 is 2, but I can still write it as 8 minus 6, and that would give me the 2. Okay, so this isn't quite right. This is still going to be circles. So I might write this. I feel bad because if this is in class, if we went this from the beginning, this wouldn't be a problem. But this is supposed to be squared here and squared here because of the radiuses. So it's big R squared times pi minus pi times little r squared. This is the area of the big circle minus the area of the little circle. And we would just always factor the pi's out. Say dx. Factor the pi's out, and then we just say r squared minus little r squared dx. We could even separate this into 2 separate integrals. But we'll talk about that in class. Don't worry about that. Okay, so if you're watching this later, this will make more sense. We just go straight to here. Don't forget your pi out in front. If you forget the pi out in front, then your answer will be a little off, but you might get some partial credit. Okay, type that in all in at once, and you get 168. I didn't round right on this. I'm gonna do it again. So I'm gonna type in pi. There's a pi button on Desmos. So pi, int for integral, 0 to 2. It's big R squared, so in parentheses, 8 minus 4 natural log. Okay, the parentheses are going to be a little bit tricky on these. Minus little r squared. I'm just going to take 2 squared, which is 4. Parentheses. That parentheses closes that one. That one closes that one. Okay, right now when I'm plugging in, I get 42. Something went wrong, so this would be a good time in the. Oh, I didn't put my square there. So I didn't put the square in here whenever I typed this in just now. If I type squared, oh, I typed in 2 instead of squared. Okay. So be careful. When I typed this in just now, I typed in a 2 instead of squared, and it was throwing me all off. But this would be 168.17954. So decimal spot, 5 numbers. We don't know if this is like square or cubic units or cubic centimeters, cubic feet. So just, you don't have to worry about right cubic anything. That would just be the answer. All right, last part. The region R is the base of a solid. And for the solid, each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. So similar to that multiple choice, the side length of each square is going to be distance from, let's erase all this. It's going to be the distance from top of the region, which is 6, minus function value. So that would give us each distance in between each one. So that would be the side of each one. So the side is 6 minus, what would that be, 4 natural log of 3 minus x. Okay, the area of each square would be that squared. So the volume is adding up an infinite number of those from 0 to 2. So again, if this is FRQ, they have to see that. They have to see this on your paper. And then you can write that as equal to, you type it in. I didn't round correctly, I don't think, whenever I did this before, so I'm going to do it again. Integral 0 to 2, parentheses, 6 minus 4, natural log of parentheses, 3 minus x, squared, dx, and I get 26.2666, yikes, and then 0, 0. Okay, so it's kind of gross. Oh well. All right, so that's it for this video. Hopefully this was helpful. Thank you for watching, and just keep doing what you're doing. Y'all are doing great. You're learning calculus at a very high level. I'm just really proud of you. If you have any questions, ask me next time I see you in class. And if you want to like write a comment, just be nice and help each other out. If you have questions and you see someone in the comments has a question and you can answer it, then answer it. Maybe you say it a better way than I say it, something easier that to understand. So thanks for watching. Bye.